Let's have a look at describing the motion of objects under constant acceleration. So objects subject to constant acceleration, let's analyse their motion, velocity, speed, distance travelled, all the rest of it. Okay, so throughout this video I will use the letter U for initial velocity, V for final velocity, T for time, S for displacement, A for acceleration. You're free to use others, but I mean, that's just for this video. I'll use those. All right, some equations for us to use. Final velocity is the initial velocity plus the acceleration times time. Displacement, S, is u times t plus the half times a t squared. A is acceleration, t is time, u is initial velocity. Final velocity squared is initial velocity squared plus 2 times acceleration times the displacement. And here's the average one. S is a half u plus v times t. Okay, and the average velocity is the change in s over the change in time. So the change in displacement over the change in time is your average velocity. Okay, so let's have a look at some examples first. All right, so a particle moves in a straight line from a point O with constant acceleration and with initial velocity 20 meters per second. After 20 seconds, it is at 0 again. Okay, now we can define to the right as positive. All right, and then movement to the left is negative. Okay, so the acceleration of the particle and the velocity at which it returns past O. So the initial velocity is plus 20 meters per second. T equals 20 seconds. Okay, so it has initial velocity 20 meters per second. After 20 seconds, the displacement is, we don't know, we'd like to find that. What is acceleration? We don't know, we'd like to find that. And what is the final velocity? Okay, so looking at the equations we had before, we've got U, we've got T, we've got S is 0, S is, sorry, did I say we didn't know that? My apologies. S is 0. After 20 seconds, it is again at O, so the displacement is 0. My apologies there. And U is 20, T is 20, S is 0. What is A? What is V? So what are we missing? Well, in this equation, we've got S, we've got U, we've got T, we've got T. The only thing we're missing is A. We can solve that for A. And generally, that's how these problems go. All right, so S equals UT plus a half AT squared. Put S as 0 in there, then we have 20 times 20 plus a half times A, the unknown, times 20 squared. Straightforward. 20 is 400. A half times 400 is 200, so we have 200A. 400 plus 200A is 0. A, solving that for A, we get minus 2. So the acceleration is to the left. Okay. All right. What is the velocity at that time? At t equals 20 seconds. Well, we know u is plus 20, so we have plus 20 plus negative 2 times t. When we work that out, this gives us minus 40 plus 20 is minus 20 meters per second to the left. So as t equals 20 seconds, the object is moving definitely to the left. All right. Now, when and where the velocity is 0. Okay, when and where is the velocity 0? All right, we know the initial velocity, 20 meters per second to the right. When, we don't know. Its final velocity is 0 because we're told that. Where is the velocity 0? A, we know is minus 2 meters per second. So the only thing that's really missing is t. So, and the equation that has just a t in it, and all the other variables that we know, v equals u plus at. Put v is 0 in there, u is 20, a is minus 2 times t. We have 20 minus 2t. Solving for that is equal to 0, sorry. Solving for that, we get t equals 10 seconds. Okay, so when the velocity is 0 is 10 seconds. Where? Okay, we can find that out. We have a choice of equations there, but this one is handy. S equals a half u plus v times t. Well, v is 0, u is 20, a half times t is 10, so S is 100 meters. So it's 100 meters from the origin where its velocity is 0, okay, and the acceleration is directed towards the left. So from that point on, it's going to start moving back towards the left. Okay, let's have a look at a different kind of problem now. one that involves constant acceleration. This constant acceleration is that due to gravity. So that's the gravitational acceleration g. Okay, now a ball hit by a bat leaves the bat traveling at 15 meters per second straight up. Okay, so some ball's been hit by a bat, and now it's going to start traveling up. So its initial velocity u will be 15 meters a second. Okay, we're going to set g for us. We're going to set g to be 10 meters a second squared instead of 9.82. Just rounding it off, just for the sake of this problem, just makes it easier. That's all. Okay, again, I'm going to choose up as plus, and so this will be acceleration due to gravity is down, so that will make that negative. So for the ball's motion up to the highest point of its flight, the initial velocity is 15 meters per second. The acceleration due to gravity, which we are going to round off to 10, and it's going to be negative because in our diagram it's going down. So it's minus 10. At the top of the ball's flight, the velocity is momentarily, for an instant in time, it's going to be 0, and then it'll begin to fall back down again. Okay, so as it goes up, its velocity will decrease, and then at some instant in time, its velocity for an instant will be 0, and then it'll fall back down. Okay, so we set at this point v equals 0. Okay, so we want to find the maximum height. How high? What's the displacement it goes? We know the final velocity will be 0. We just don't know what x is. Okay, I've swapped to using x here. In the previous videos I was using s, but this time I'm going to use x in the previous part of this video, sorry. So v is 0, x, the displacement. Okay, well, the equation we can use is v squared minus u squared equals 2ax. Now on the previous page I think I might have written something as v equals u squared plus 2as. Okay, but that can equally be v squared minus u squared, okay, equals 2ax for us. Okay, so put in the information. V is 0, so 0 squared minus 15 squared is equal to 2 times minus 10, remember it's going downhill, heading down towards Earth, times x, whatever x is. Okay, solving that equation, we will be able to find that this is x is minus 15 squared over 2 times minus 10 is minus 20, so the negatives will disappear. When we do solve that on the calculator, 15 squared over 20 will give us 11.25. Alright, so it'll only reach 11.25 meters above the ground before there's an instant, before that instant where that's its maximum height, and at that instant the velocity is 0. Okay, now the time that the ball is in the air, okay, for the upward flight, u is plus 15, v equals 0 at the height, a is minus 10 for us, and t is, we don't know, that's what we want to find. Well, we could use the equation v equals u plus at, rearrange that gives us t equals v minus u over a. Putting in the relevant information, 0 minus 15 on 10, we get t, the two negatives cancel, we get t as plus 1.5 seconds, as we should. It's very important to put direction into these problems, because had I taken g as 10, we would have had a negative answer here, which clearly doesn't make sense. So direction matters in these problems. You must set up a direction system. If the ball's going up and we're choosing up as positive, that's fine. You could have chosen up as negative, it's up to you, as long as you are consistent in your choice of directions. Okay, for the downward flight, the initial velocity is 0, just for an instant. It's going to drop a distance of 11.25, so minus, because we're going in the downwards direction. A is minus 10, so again, it's pointing in the negative direction. What is t? Okay, now use x equals ut plus a half at squared. You've probably already guessed what t will be, and you will be right. But let's move on. Okay, x is minus 11.25, u is 0 times t plus a half times minus 10 times t squared. Okay, well that bit drops out. Minus 11.25 equals a half times minus 10, so that's minus 5 times t squared. So that's a minus 11.25 divided minus 5. Okay, gives us t squared is 2.25. And when we take the square root of that for t, we get 1.5 seconds. Exactly what we expected. The ball takes 1.5 seconds to go up and 1.5 seconds to come down again. Okay, so the total time of flight to go up and down is now 3 seconds. All right, now Part 3. What was part 3? We wanted the times at which the ball is 10 meters above the height at which it was hit. Okay. Now, we want at what times t is that ball above the 10-meter height. Okay, so consider the moment it leaves the bat until it's 10 meters above the point it was hit. So u is plus 15, a is minus 10, x is plus 10. We're going up. T is something. Okay, well, we can use our equation x equals ut plus a half at squared. X is 10, u is 15 times t plus a half times minus 10t squared. Okay, what we're now going to do is tidy this up. So this half times minus 10 will give us minus 5t squared. So what we'll do is the minus 5t squared, we can take over this side here. Okay, take the 15t over this side, minus 15t, the 10 is already over there, and all that's equal to 0. Next thing we can do is divide through by 5. Okay, so we get 2 minus 3t plus t squared. And write that as t squared minus 3t plus 2. Factorise that. T minus 2 times t minus 1 is equal to 0. Null factor law says t equals 2 seconds and t equals 1 second. So after 1 second on its way up, the ball was 10 meters high. And again, 2 seconds after it was hit on the way down, on its way down, it was 10 meters high. So 2 seconds after it was hit up, it's reached the top of its journey at 1.5 seconds. And then half a second later, at t equals 2 seconds, it's back at the 10-meter mark again. Okay, it first encountered the 10-meter mark above the ground at 1 second, and then another second later it was back down at 10 meters again. Okay, and that's it.